Okay, right, yes, thank you everyone for coming. So this is a Comet Section meeting. I nabbed it last year, and unfortunately the Comet Section director, Jonathan Shanklin, can't make it this weekend, so you're going to have to put up with me as assistant director running the meeting. We've got a stellar lineup of speakers who I confirm are all in the room at the moment, which is good. So Richard Miles is going to be talking about outbursting comets. Damien Peach is going to be hopefully telling us some secrets about how he obtains those fantastic images of comets that we will have all seen. And then after the tea break, Kevin Hills is going to be talking about VEMs, visual equivalent magnitudes. So for any variable star people in the audience, they'll start to feel at home because it's all about measuring magnitudes, numbers, light curves, all that kind of thing. So what I wanted to do just as an introduction was to talk a little bit about the Comet Section, what it does these days, and the kind of things that we can do as amateurs to contribute to comet science. So the first thing is that we don't just observe comets to get numbers or because of the science involved. I think, and I'm a bit biased, I know, that they are the most beautiful objects in the sky. If you do get a really good comet, and this one is Comet 2006 P1, discovered by Rob McNaught. This is a sun-grazer comet. This is the moon down here. Wide-angle view, incredible view of the tail of this comet. We've seen some other ones in sort of living memory. This is Comet Hyakutake from 1996, an image that I took from Tenerife, top of Tenerife. This is about 30 degrees from one side to the other. Again, a comet with a lovely tail. But the big daddy of them all, for those who are old enough to remember it, is this one. This is Comet Hale-Bopp from 1997. This was a huge comet that hung around in the sky for months. So we should never forget when we're observing these things that, yeah, the science is important. It's important to know what makes comets tick, but we do it because we enjoy it. These things can be beautiful objects. The other thing about comets is they're probably one of the most unpredictable things in the sky. This is Comet 17P Holmes. And Comet 17P Holmes went from a comet that was about 17th magnitude, so kind of well beyond what most people could see in a large telescope, to being visible from the middle of Piccadilly in London overnight. And there's not many objects that rise in magnitude by that much in such a short time. Of course, that was a good unpredictable thing of comets. There are other unpredictable things, and this one is one of the more infamous comets that we've had, of course, from a couple of years ago, Comet 2012 S1, ISON, which was the comet of the century until it wasn't. And of course, we all know what happened to ISON. It went too close to the sun, and it ended up basically being fried and fell apart. So I think comets are really interesting objects because they're beautiful, they're unpredictable. You never know when you go out to observe a comet what it's going to look like. I know a lot of people in here enjoy deep sky observing, and I do too, and deep sky objects are beautiful, but when you go and look at them again, they're pretty much the same as they were last year. They're pretty much the same as they were thousands of years ago. Comets, you never really know when you go to the telescope or you image them what you're going to see. And of course, all of this majesty and all of this interest comes from a really small nucleus in the centre of the comet. And up until recently, we haven't actually been able to see the nucleus. We've been able to see the effect of it in terms of the gases that come off that form the coma and the tail and the dust. But we haven't actually been able to see the nucleus. Spacecraft have flown past comets and have shown us that the nucleus is actually a really weird place. It's this is the first one here. This is Halley. It's sort of peanut shaped, and then other comets. None of them are kind of nice, simple places. But of course, the one that everyone's interested in at the moment is this one. This is 67P Churyumov-Gerasimenko, taken from the Rosetta spacecraft, and this is an absolutely fascinating comet. I mean, who would have thought before we went there that it was actually this weird shape? But this is a really interesting object, and as I'll say a little bit later, it's something that we as amateurs can actually contribute to some of the science associated with this. And I think doing that, certainly from my perspective, I really enjoy observing comets for lots of reasons, but it helps me, I think, and it improves my enjoyment of observing if I know a little bit about what's going on and understand a little bit about some of the physics and processes that are going on, and also that some of my observations can possibly be used even in a really small way by people to improve the science return from much bigger things like the Rosetta mission. So that's the intro. What's the first sort of thing that amateurs can do with comets? And here we go into kind of variable star territory a bit. But light curves. Light curves are the most obvious way of characterizing a particular comet. As the comet gets closer to the sun and closer to the Earth, as it gets closer to the sun, its activity increases. As it gets closer to the Earth, we see it as being brighter. And by measuring the light curve, it gives us some idea about how the comet's behaving, how big the comet may be, how active it is, and also if the comet does something anomalous. So you might have a comet which follows a nice light curve and then all of a sudden brightens or fades. Now this is one of the areas where visual observers are still very important, and I think we've seen this morning in terms of the way that technology has changed what people do in astronomy, that technology is now really very dominant in what a lot of us do as amateur astronomers. But there are still certain areas where visual observers are absolutely crucial, and one of those is in estimating the magnitudes of comets. And you might ask why that is, now that we've got all of the very advanced sort of digital cameras and stuff that we use. And the main reason is that comets, unlike variable stars, are really difficult to estimate magnitudes. They're not point sources, they're fuzzy blobs. And visual observers have got a long history of making magnitude estimates of comets. So if what you're trying to do is, say, compare this return of 67p with the return 2 or 3 orbits ago, the only way you can do that is to have visual observations in order to calibrate the electronic observations that you make of the comet. And that's why visual observations are still extremely important. It's the only way that we can sort of look back in the archive and say, okay, this comet is behaving differently to the way that it performed 50, 60, 70 years ago. And also visual observations in the field of comet, visual magnitude estimates in the fields of comets are probably still at the brighter end more accurate than you can make digitally unless you follow a very, very specific procedure. So visual comet observers are still very important, and unfortunately there are fewer and fewer of them around. So if any of you don't want to do the sort of digital stuff, there's still a real opening there in terms of comet observations visually. The problem with visual is that you can only really do it for fairly bright comets. So the very brightest comets that you might do naked eye or binoculars, and then comets down to maybe Mag 10, maybe Mag 11, something like that with telescopes. But below that it becomes extremely difficult to make visual observations. And so what amateurs have been trying to do for quite a long time is find a way of making magnitude estimates using digital techniques, CCD cameras, that actually in some way match the magnitude estimates that visual observers make. And that's what are called visual equivalent magnitudes, and that's what Kevin will be talking about after tea. And it's based on a lot of work that Roger Dimmock has done in basically pulling together all of these techniques. And so hopefully what Kevin will do will show you that in fact this process is relatively straightforward, and that if you're imaging faint comets, it's really helpful if you can do the magnitude estimate as well. So some comets are so faint that really they're just like asteroids, and they really are just point sources. And in those cases, I mean, this is an object sort of about 15th magnitude or so. You can use programs like Astrometrica, which I know a lot of people in this room will be familiar with. One of the best, if you're a comet observer or an asteroid observer, this is one of the best programs out there for both stacking frames and doing measurements, both measuring position and measuring magnitude. And Astrometrica does a really good job of doing that, as long as the object that you're measuring is fairly compact and doesn't have an extended coma. So if it's an asteroid, it's a point source, and if it's a comet that's not very active, it's effectively a point source. You can measure the magnitude directly. And what Astrometrica does is it uses the stars in that image, it compares them with the magnitudes from a catalogue, It does it in particular photometric bands if you have the appropriate filters. If not, it can do sort of, you can assume a band for your camera, either R or V, and it does a reasonably good job of producing magnitudes. And these are the magnitudes that are generally reported by a lot of people to the Minor Planet Center. So the Minor Planet Center is the place that collects all the astrometry for asteroids and generates the orbits of asteroids and the ephemerides that you get. So if you use programs like Starry Night or whatever, they'll have ephemerides in which will tell you of a comet, and it'll tell you a magnitude of that comet. And quite often the light curve of the comet is based on the magnitudes that are reported in these astrometric type reports to the MPC. And for most comets, those magnitudes are actually too faint, because what Astrometrica is doing is measuring the light in a small aperture rather than the whole light of the coma of the comet. So to get over that problem, a group of Spanish observers have written a really nice add-on for Astrometrica, which is called FOCAS. And what this does is it uses Astrometrica as the basic way of registering and measuring the image, but then it analyzes the output from Astrometrica to calculate the amount of light in a set of concentric apertures around the center of the comet. So you can see here that there is the magnitude in a 10 by 10 arc second, 20 by 20, all the way up to 60 by 60 arc second box. And for, again, relatively faint, relatively compact comets, this is a very good way of obtaining magnitudes, because what then happens is you can process this, which is basically the magnitude gets brighter and brighter as the aperture gets bigger and bigger, because you're including more and more of the coma, up to the point that effectively the coma disappears into the sky background. You can process that and you can get this total magnitude of the comet, this visual equivalent magnitude of a comet. Now, Roger has got a set of pages under the BAA Comet Section, which is called the Project Alcock set of pages, named after George Alcock. And the procedure for doing this is written down there. And Kevin's going to be running through a tutorial of that after tea, live, so anyone who's interested can follow through and see how it works. So that's a really good technique, and really we try and encourage as many people as possible to adopt that. If you're taking images of comets, this is something you really should be doing, is measuring the magnitudes as well. And then you can submit them to this, which is the Comet Observations Database, which is a really useful resource, collecting comet magnitudes and allowing us to collect the data and plot light curves. It used to be that these magnitudes would have been submitted to what's called the International Comet Quarterly, but that seems pretty defunct now. I don't know if anyone else has any opinions, but the ICQ, which was the official sort of depository of this information, seems to have died. So COBS has taken it over. So COBS is a really good place to submit these magnitudes, and if you follow the process that Kevin's going to talk about after tea, then you'll have magnitudes that are suitable to go into this database. But even then, there are some differences, and you can see this is actually the light curve of Comet Lovejoy, Q2 Lovejoy. The blue crosses are visuals, the red are CCDs, and you can see that the CCD observations have got huge scatter compared to the visual. Now, that's completely the opposite of what you get in variable star, where visual observations have a much larger scatter than CCD. But in the case of comets, the problem is actually, when you're doing a measurement using a CCD, is defining how big the coma is, what aperture you're using, how much light do you include. And it's a particular problem for this comet, which is a really large comet. So really these techniques, the FOCAS technique, doesn't work, because you're trying to extrapolate over far too large a coma. So the other alternative is that you use a wide field instrument, and so this is an image of Lovejoy taken with a wide field instrument. It's something like 2 and a bit degrees by 1.5 degrees here. And again, using Astrometrica, what you can do is, because the comet is moving relative to the stars, Astrometrica can either stack your images stationary on the stars, or it can stack the images so the comet's stationary and the stars are trailed. So if you stack stationary on the stars, you can use astrometrica again to measure the star brightnesses in the image, and that will give you a reference or 0 point for the magnitude estimate. You can then restack those images offset on the comet's motion, and then what you can do is you can effectively have a look and see how big the coma is and measure the actual total counts within the coma diameter. So the key thing of measuring accurate brightnesses for these very large comas and these large comets is getting a good sky reference, because you can imagine that towards the edge of the coma is actually quite a large area, but it's only just above the sky background level. And any errors you get in the sky background directly lead to large errors in your estimate of magnitude. So there's absolutely no point trying to make a magnitude estimate of a comet that's got a coma 20 arc minutes in diameter using a field of view that's 10 arc minutes and trying to extrapolate out. That just won't work because you've got no sky reference, you've got no way of fitting. So for these very large comets, bright comets nearby, you do need large field instruments, in the same way that visual observers would never make a magnitude estimate of a comet like this using a large aperture telescope with a high magnification. They'd use binoculars. They'd use the smallest instrument that they could that would actually allow them to clearly see the comet and estimate it. So you can do that. That's relatively straightforward. Any program that can do aperture photometry can use this approach. I've done it on Lovejoy, and I get magnitudes that are pretty much in line with what visual observers have been getting. And then there's another approach which is a much more mathematical one, which is you can actually analyze the comet and fit effectively a shape to the coma, and then mathematically integrate the light in the coma. Again, it depends on very accurate calibration of the sky background. But all of these things are ways of measuring magnitudes, and certainly in the case of the FOCAS, which is mainly used for the fainter comets, it's something that we'll cover later on, and I'd like to encourage as many people to do as possible. So that was magnitudes. The other thing that makes comets interesting is outbursts. There are a number of comets that for a long time have been known to have outbursts. This one with the lovely name Schwarzmann-Wachmann has fairly regular outbursts, and amateurs can monitor these comets much more easily than professionals can, because we have a lot more access to telescopes around the world in different places, and we can actually look for these outbursts. And there are a number of people in the Comet Section who are regularly imaging comets to look for these outbursts. And this is one that Richard Miles has recently detected. This is our old friend 17P. So this was a recent outburst of 17P. This was an image of mine taken in January, and there it is, nothing very remarkable. It was about magnitude 18 point something at that point. Richard Miles noted on some images he had taken with the 2-meter Fulks North telescope that it appeared to be an outburst, and circulated a message to the BAA Comet list. And on that night it was clear in Chelmsford, and I managed to get an image of it. And here it had gone up to something like 14th magnitude and had this very interesting shape. So you can see a sort of fan shape moving away from the nucleus. So this comet is obviously prone to outbursts, and Richard will talk about that in the talk next, and some possible reasons for it. But it's interesting to compare this. This is an image taken with a Celestron 11 in Chelmsford. So you can see the nucleus here in this fan. This is an image taken with the Fulks Telescope North 2-meter telescope on Haleakala, and obviously it has much better resolution. But it shows that even relatively small amateur telescopes can actually be quite useful for comet imaging in this case. An outburst is something that people are certainly interested in detecting in comets, because again it tells us a lot about what's actually going on. If we can understand why comets are outbursting, it'll tell us a lot more about what comets actually are. And this is it had faded. This is one of Peter Carson's pictures. It had faded back down again in March to pretty much obscurity. So the idea is that with automated telescopes you can image these comets frequently at the rate of sort of once every few nights or so, or even more frequently than that, and look out for outbursts, and if you detect anything, you can direct people to it. And outbursts are relatively frequent. This looks a bit like Comet Holmes did, but this is a comet called 2012 X1, which went into outburst and had a very similar kind of features in it that Holmes did. So understanding why comets outburst is very important. Morphology basically means what the comets look like, what are they doing, and again this can be done by amateurs very well because we have access to telescopes all around the world, so we can get very good time resolution on comets. People at different longitudes can take images at different times, and here we've got Comet Lovejoy again, Ian Sharp in Spain at 1954, me in the UK a couple of hours later, and you can see a nice disconnection, or a nice event in the arm tail moving away from the comet here. And this comet, you can even take series of frames and you can see changes over hours. This is again Lovejoy, and this is the ion tail, and this is something like 2 hours of imaging of this comet. And you can see really interesting changes in the detail of the tail. And again, this is something that amateurs do really well because we've got access to telescopes. We can afford to leave a telescope running on the comet all night. You know, it's our telescope. We don't need to pay anyone to use it, unless you're using a robotic telescope, I guess. So we can keep these things under scrutiny for a long time. And this morphology applies to faint comets as well. This is a comet that's around at the moment called was it 2014 F2 Tanagra, and it's got a little tail here. And I was talking to Dennis about this the other day, and he got an image the same, so it really does. And it's something that these days we can pick up with CCDs that we would never have been able to do before with film techniques. So there are lots of faint comets out there. Keep them under observation because you never really know what it is you're going to see. Dennis will say a little bit more about this in a minute, but the BAA has set up an archive for all of these images, which is online. So we really want to receive your images of comets, whether you think they look nice or not. This is just a way of recording everyone's images of comets, and we've got every comet here with images associated with it. And I'd strongly recommend that people who image comets send their stuff into that archive. But Dennis will talk a little bit more about that in a minute. So just at the end of this talk, I wanted to just talk about this year's special comet. So who are these people? Anyone? Any ideas? It is. So yes, this is Churyumov and Gerasimenko. And this is now what Churyumov looks like, a little bit older. This is one of the contributors to actually our BAA Comet Section image archive, Alexander Baransky. If you look in the archive, you'll find he images practically every faint comet as frequently as he can from Kiev. And of course, here is Churyumov, who discovered this, 67P. And we're in an extraordinary situation at the moment where we have a spacecraft in orbit around a comet which we will soon be able to see through our own telescopes. And that comet is becoming quite active. So what the professionals really want is, okay, we're getting these fantastic images from a spacecraft in orbit around this nucleus, but this nucleus is only 5 kilometers across and the field of view of the camera is only tens of kilometers. What they want to know is what the comet's doing at a large scale. Now, professionals will be looking at this comet in great detail with big telescopes, but they won't be able to do it with very high time resolution. And they also have a problem at the moment that the comet has just gone through conjunction with the sun. It's coming out from behind the sun, too close to the sun for them to get their telescopes for quite a while. And so the big race at the moment is who's going to get the first image of 67P following conjunction. And that'll be really useful because it'll allow us to start getting points on the light curve now after a gap of 3 or 4 months whilst the comet's been in conjunction. And even though you might think, well, okay, you know, a light curve of this would be well known, of course, it changes from apparition to apparition. And having a good light curve will allow the people who are analysing images like this, like Matt Taylor, who's going to be talking tonight, to have some idea of what this comet's doing on a much larger, more global scale than what they're seeing in these very, very high resolution images. So there is a ground campaign for amateur observers that's being run out of JPL. It's got a website. I've got the URL I'll put on at the end. And what they're looking for is amateur observers who can actually observe this comet, both to get light curve magnitude estimates, but just images as well, just to watch the comet if anything unusual happens, if an outburst happens or anything like that. So I'd strongly suggest you sign up for this. It's got a Facebook group as well. If you're on Facebook, it's worth getting signed up to that group, Facebook group, because we're coming up now to the big time in this comet, coming up to perihelion in August, and the comet's brightening up. It's not ever going to get particularly bright. This is the nuclear magnitude. It reaches about mag 13.5 in August at perihelion. Its total magnitude probably will be somewhere around 10 to 11, something like that. It's not going to be hugely bright, but it's not faint either for images these days. The problem is that it's not ideally placed for us. So these three curves, this shows the elongation. So it's just been through conjunction. It's coming out from conjunction now. This is the distance from the sun. This is the declination. It's moving north, so that should be good for us. It's moving away from conjunction, which also should be good for us. But unfortunately, our nights are getting shorter and shorter and shorter because of the summer. So Richard Fleet produced this wonderful piece of software years ago. I don't know how long ago, but it was a very long time ago. But it's still very useful. It allows you to show the visibility of cometary objects. So what we've got here is a red curve, which shows when the comet's between about 0 and 10 degrees altitude, a green curve, which is 10 to 20, and so on. And you can see from our latitudes, really, that we're only going to see it at a reasonable altitude after the summer, so probably after perihelion. So really, we're looking at remote scopes. This is my scope in Chelmsford, but this is a scope I have equal access to, just using the iTelescope system at Siding Spring Observatory. Now, one of the problems with these scopes is they're in big sheds and they don't have particularly good horizons, but this one, I'm telling you this is a secret because I've booked it for the next few mornings, has got actually about an 18-degree limit in the east, which is where this comet is, and it's probably about the best instrument in the iTelescope set for recovering this comet. So in the southern hemisphere, we're now at this point, this red line is the middle of April, where the comet's just about reaching above 20 degrees in the morning twilight, and so it should be recoverable very, very soon now. This is from Siding Spring a couple of mornings ago. This is the moon, annoying in the sky as it always is. And this is the twilight, and this red blob shows where 67p is at the moment. And the limits, the altitude limits for this telescope is just a few degrees above that. I took an image on that morning of about the same altitude just as the roof was closing. The roof closed halfway through this imaging sequence. So you have to be right at the point where, you know, the imaging is about to finish to get this. But I'm pretty confident that within the next 10 days or so somebody will have recovered this comet. And that will be a big thing, because that will start giving us new magnitude estimates of this comet as it moves in towards the sun, and it'll be something which will allow the Rosetta Project scientists to know how the comet's behaving compared to previous apparitions. So in this very, very brief talk, I've tried to say what I think we can do as comet observers. I think this is really exciting. It's one of those occasions where we can do observations and know that we're doing observations which the professionals will be using, and there's a lot of interaction on the different groups there. I would strongly suggest that if you are doing comet observing, that you sign up to this, the ground-based campaign, and if you do that, send all your observations to them, but also please send them to us in the BAA. If you don't want to sign up to that, still send your observations into the BAA, and we can make sure if anything is interesting there that we can pass it on to the relevant people. So I've got 8 seconds left, and Dennis has asked to speak for a couple of minutes on our image archive. So Dennis, if you want to just come up. Right.
I'll start speaking before you.
Yeah, you start speaking. You've got 2.5 minutes.
I just want to say a few words about the Comet Image Archive, because we really set this thing up about 12 months or so ago, incorporating a lot of the old BAA Comet archive and also the Astronomer Comet archive, incorporating them together to make them a bigger archive. And what I want to do today is just to mention really that we're interested in receiving not only current images for our archives to give us a complete record of what comets are looking like today, but I'm after also archive images of older comets that maybe you have got in your collections. Now this could be photographs which you're prepared to scan and send these images. I'm sure you've all got pictures of Hale-Bopp and that bright comet Halley when it was around. If you want to scan them and send them into us to keep in our archive, I will be very pleased to receive them. We've obviously got a specific file format, so if you scan them as JPEGs and follow our file naming format, then we can place them in our archive. And it's very important that we try and build up this archive as well. And you can see here that Nick mentioned this chap Alexander Baranski, and I just wanted to really highlight this guy because he's one of our main contributors to the Comet Archive. And as Nick says, he does absolute masses of faint comets and does them almost every night at this observatory. And he says he's an observatory as a volunteer, but his main job is a fellow of the Kiev National Botanical Garden. So it's not his main job, but it's his night job. But the amount of time he spends doing comet imaging is quite incredible. Next one, Nick. This is the telescope that he uses, his 70cm reflector. And I really wanted to make the point. Next one, Nick. I want to make the point that he's still working in Kiev, and this is Churyumov there, who also imaging with him, still doing some comet imaging, even though his moment was years ago in discovering this comet, but he's still actually interested in making observations of comets in today's environment. So it's great to see these people still working at the actual coalface, if you will. And Baranski sends images in probably about 50 a week, and that's no exaggeration, maybe 50 comet images a week, and this is a typical images of his, and the amount of measurement and information he gives for each comet image is quite fantastic. And I think that it would be good if one or two more of us could follow his example and send plenty of information. And that's it, is it?
Okay, yeah, that's good.
Okay, so please send them to me. You'll find the information in the BAA Comet Section website of the file form.